Roger Bisbee from the Skill Builder channel. We've come down to Rye in Sussex. Now, we're not on holiday, we're here on a serious mission because this hotel is one of the first ones in the country to go completely carbon neutral. They are off-grid, and even if you don't buy into the idea of global warming, climate change and all the rest of it, there is a lot to be said for releasing yourself from the tyranny of the people that sell us our power. So later on we've got a few important guests turning up, but now let's go and meet the owner, Javid. So we actually stayed here last night and had a very nice breakfast this morning, so we've already got our feet under the table. But let's meet Javid and his lovely wife Judith.
Roger, welcome.
Who are both the joint owners of this enterprise. Now, carbon zero. A lot of people talk about carbon zero, don't they? But your idea is that you've made this off-grid.
More or less.
Okay.
We're beyond net zero. We just don't burn hydrocarbons at all.
So what was the idea behind this?
Partly because of climate change, and also had the opportunity to completely refurbish a building. So I thought I'd just bring it right up to standard and then beyond. And my last place, that was a grade 2 listed and had god-awful utility bills.
And it was a nightmare.
And it was an absolute nightmare.
So you just don't like paying bills? It's not that you want to save the planet, you just don't like the bills, is that it?
I think they're not mutually exclusive. So we're going to start with the electrical cupboard. Now we have about 34 panels up all over the roof, which comes down to the 3-phase inverter, goes to my distribution board and then to the building, and I'm in the process of installing a battery system based on Pylontech. Each battery is 5 kilowatts.
Is it?
So I've got 15 sitting there, and eventually I'll probably take it up to about 35 or 40 to match my average solar production. So now we come into the plant room proper, which starts off with a cold water tank, which basically drives all the bathrooms and showers and things. That way we never lose pressure.
So you're not relying on the mains pressure. This is basically the mains is coming in here and it's being boosted by the pump.
Yes.
Is that right?
Because I've only got a 25 mil water supply coming in, to have increased that to 2 inches would have cost a stupid amount of money.
And is this drinking water?
Yeah.
Be fine.
Which means we also get drinking water out of all the taps.
Adam.
Hello Roger, how are you?
Peter from Mixergy.
How you doing Roger?
Hiya.
Hi
And
Roger, how are you doing?
Simon, my arch enemy. Let's go and have a look.
So this is the plant room, which the electrics are at that end. Got a pressurised 400 litre cold water tank, which provides cold water, drinking water as well. The 2 Mixergys with the heat exchanger plates. We have the PV switches. I just put this up here just to have an old tablet so I can control everything. And then at the very edge there we have the 2 Eddi diverters, which are working on different phases. So I've balanced it so that one tank's on phase 2, the other tank's on phase 3, and most of the house circuits are on phase 1. That way I'm maximising the solar production going into the tanks, because the solar production can peak at 11 kilowatts. Had the manifold custom made, and this was in view of a gas setup, and I specifically wanted each room to be zoned. Then I watched your video, and rather than switching rooms on and off, I now have the ground floor permanently heated, the first floor permanently heated. I took the flow temperature from 55 down to 40, and I was really fortunate in being able to put the heat pump right on the other side of the wall there, so it's a really short run. But one thing I don't know, and what are those blue things?
Balancing valves for your returns from the rooms.
Right. And given that there is a flow and return circuit, do they need balancing? Because I don't think it ever was. I don't know if it's even relevant.
It depends how far your rooms are on plastic pipework.
Are they going to the ThermaSkirt or the underfloor heating, or both?
Both.
So on the ground floor, it's going to underfloor heating circuits, of which there are 3. And then, yeah, every single one for the first and second floor is to a ThermaSkirt.
I've never installed ThermaSkirt. I don't know if it has balancing on the ThermaSkirt already, but your underfloor heating manifolds will all already have balancing on them. I think that's an overkill. Normally you balance at the emitter.
Right.
This is usually for a different kind of setup where you can't balance for some reason in the area. Where's the heat pump?
Right here.
Outside there.
Is it 12 kilowatt?
That's a 12, yeah.
And how many, do you know how many square metres your home is?
About 300.
40% oversized.
Is it 300 meters?
I tell you why, I've just allowed 30 watts per square metre because he's got so much insulation in there, which has given me 9 kilowatts load. You probably could have gone with a slightly smaller unit. If they do a 10, I think you would have got away with it personally.
That was lucky because I just bought it. Thinking,
it's not many
big.
miles out. Yeah.
It's not miles out, is it? So
No,
the unit sizing
you're
is
roughly,
all right.
and it's certainly better than the 212s you were quoted by people who hadn't done a heat loss calculation before.
Yeah.
Was it second hand?
No, but it
Because
was
I noticed the damage in the front.
Dropped?
Yeah, I think someone drove a forklift into it. So I got it brand new, but it was lots of money off.
Cool.
That's
So I
just
thought,
cosmetic
Well-
damage then.
Samsung are cheap anyway, so you got double savings. How are you controlling? So you said you set the controller to 40 degrees.
Yep.
Where is that controller?
the control interface is there, the brains is in that box.
Right, so you've got a set flow temperature of 40 degrees.
Yeah.
Well, that's why you're nervous, because you're not using weather compensation. You set your flow temperature for what you want it at -2, and then for the rest of the year, as it's warmer, you should have a lower flow temperature continuously. That's how you get maximum efficiency out of this. You've set what you need for -2
Yep.
for when it's 10 degrees outside, which is unnecessary. So you're unnecessarily cooking the water, essentially. So the first thing I would suggest is to turn on weather compensation. To get the lowest flow temperature possible, you can adjust your curve, which is how hot you want the water relative to the outside temperature, incrementally, and you can look on your thermostats and you can see if it's just going under or just going over live before you get any complaints. And then once you've got it on, you just leave it, and then you're at the maximum efficiency you could ever want. Where it might get a bit hairy is where you've got rooms turning on and turning off.
That's why I just leave everything on a very long running schedule. That's after watching your videos, actually.
Yeah, that's what you do. You set the flow temperature as low as possible and then leave on as long as possible, and then you're constantly feeding the thermal mass, which is the property. Simon, what size are the primaries?
I think they are 28. Yeah, they are 28. And what we have is a low loss header, gas boiler low loss header. 1 grand for 2580 and only 1550 for the system, which makes me think that because you've got a very small pump pumping your water around your heating system and a massive pump doing very small circuit between the header and the heat pump, that you probably can get away removing that and removing that pump. Most likely this is not needed.
Really?
Yes. And you're probably losing efficiency on having this kind of a setup if it's not balanced. Right. Unless there are other pumps that we haven't seen yet.
There's no more pumps on the emitter circuits.
Which is actually a good news, because on those setups we quite often see 3, 4, 5 pumps. You would see that, yeah. So you having just 2 pumps is actually not that bad. What are all those third-party controls? What do they do? What do they control? How do they control it? Are those thermostats able to fire a heat pump or not?
No.
Oh, that's great. That's good.
All they do is open up the valves, because when I started a gas boiler and was using that with my Hive thermostats, when the boiler went, I took the Hives off, and I just use these just to open up the valves into each room, so I control it from down here. Yep. They're not thermostatically controlled.
Oh, they're not
from
thermostatically
outside.
controlled?
No.
So are they just time controlled?
Yeah.
Okay, so that could be improved by actually having a remote sensors in the rooms and setting the rooms slightly higher to what the comfort temperature would have been. So we don't have zones that are shut that could have been otherwise opened, limiting the how open the system is.
The way I've worked it, and this has all been completely trial and error, low level heat on the ground floor, heating the first floor, and I can't remember the last time I actually switched on the heating for the top floor, because the top floor just gets warm anyway.
That you should be able to address with balancing. So you want to control more flow to the lower rooms than you do the higher. You want permanent flow around everywhere. You just want less flow higher up because you need less energy up there. Yeah. The best way is to control the building, especially a building like this, as one zone, because you've got all this extra insulation around your outer shell. Yeah. You would look at the inside as one space you're heating rather than these walls that are between. You would just control. So that's called the thermal envelope that you've created around the property to insulate it. Everything inside is finding it hard to get out anyway, so it's going to share heat between rooms easier than it's going to find it to get outside, if that makes sense. You send excess PV to your Mixergies. Did you think about perhaps figuring out how to send that via the heat pump to multiply your PV heat to then... Because if you get 1 kilowatt of heat from your solar, You can turn that, sorry, 1 kilowatt of electricity from heat from your solar.
Yep.
You can turn that into 1 kilowatt of heat for your tanks. Great. Or you could multiply it through 4 through your heat pump. Then you'll have more excess solar for the rest of the property or to export to grid and sell.
Does Eddi have switch for external heat source? It does, doesn't it?
On modern heat pumps, I don't think the Samsung has it. Samsung is lower end.
Yep.
You can have smart grid ready connections when you start exporting. It can turn on any one of these switches for this smart grid ready, and you can adjust settings. So you can adjust settings for your stores. However, we've actually been working quite a lot with Mixergy recently, and they're introducing the Heat Geek feature or settings, which are going to change. So we did a review on Mixergy, and we've been talking about them since. It's going to kind of change the operation of heat pump controlled Mixergys, whereby instead of controlling the volume of water, which it doesn't really do with heat pumps anyway, it will control the temperature of the water. So if you start exporting, it can increase the temperature of the store, turn on the heat pump, multiply your PV energy, a little bit complicated to follow, and drink up that energy into these stores when you have it freely available. Then if you generate, I don't know, 20 kilowatt hours a day, you can just use, instead of chucking it all in here, just use 5 of those, multiply it through your heat pump by 4, and then have another spare 15 to either export to grid or use with what other appliance.
There's even more I can get out of this.
Yeah, loads. The other thing Mixergy have done recently is, one of the issues we found with their efficiency was that they send an unintelligent on-off signal to the heat pump, so the heat pump doesn't really, it just has to fire extra high. They've now replaced that with a pass-through sensor, so it's sending more intelligence back to the heat pump, and it can basically reheat in a more intelligent way. So yeah, Mixergy are kind of the ones to watch at the moment.
The big one for me was I could physically fit them in here because they're nice and slim as opposed to having a short.
That's more efficient anyway with cylinders because they stratify more, so it will keep the cooler water at the bottom, which is better for the heat pump, and the heat's at the top. The other wise decision about Mixergy, this is, so I don't know if Mixergy historically were the most efficient. They were certainly up there amongst the most efficient. In this scenario, I would have suggested Mixergy's because you're going to have an empty property sometimes and a completely full property other times, so Mixergy was absolutely the correct solution to go for in this property. Here's the things that I don't like that I'm looking at. This insulation is like, you're losing so much heat here. Your heat pump is having to go hotter and burn for longer or generate heat for longer unnecessarily because you're just losing heat into the atmosphere. Like all of these brass valves, these should be covered. These are completely uncovered. The wiring should be like clipped and neat. The thing about neat installations is it can seem like perhaps snobbery to some people, but when you get an engineer come and work on this system, if it's a mess, they'll leave it in a bit more of a mess, and then you'll leave screws out, and over time it will get messier and worse, and it will just start failing essentially. By having a neater installation, you always end up with it being cared for much more. So if an engineer goes to a neat installation, they always take a bit more pride, a bit more time, and they look after your big investment. Mixergy are upgrading their plate heat exchangers or slightly bigger heat exchanger ports that will allow more flow. These have quite small ports which might restrict flow and cause more pump energy to be used. I mean, we've only just got here. Have you got anything that you're kind of spotting?
Well, we've got 12 kilowatt unit, which would require around 2,000 liters per minute when it's doing either heating or hot water, and we've got a thing we don't put on large heat pumps, which is a Honeywell diverter valve.
Right.
They tend to cause problems. They've got high pressure loss, and they tend to lose the ball. Did
you do a heat load calculation and size each emitter for each room? Like how, or did we just guess, or like what's the?
It was an educated guess in that because when I was ordering the ThermaSkirts, I just had to make certain assumptions about what heat loss I'd have because no work had been done yet.
Well, yeah.
So I went to ThermaSkirt and said, these are my room dimensions. I'm going to run it at a 50 degree flow temperature. So let's overspec it slightly. And then had it installed and hope for the best.
This is the thing about ThermaSkirt. You've either got the 2-pipe selection or the 3-pipe. There's not much design going in there. You may as well just pick the 3 level one all the way around. With the underfloor, how did you do the spacings and things with the underfloor? Was that kind of educated guess type work as well?
Again.
Right, fine. You're so well insulated, you're always going to be right. And if one's incorrect, you can use your balancing valves to just tweak between them. So you're kind of...
Because I've always wondered about those things.
Yeah, that's your fine tuning. So anytime you see, oh, I'm turning off that room a lot, it's getting up to temperature very quickly, that room, instead of turning it off and turning the thermostat, just tweak the valve down, and what that'll do is push more water into the other rooms that aren't getting up to temperature as quickly, and eventually you can start lowering your flow temperature a little bit more because it's getting the heat around more efficiently. The point that Simon made was probably the biggest point out of all of this about the fact you've got hydraulic separation, your low loss header. I think just run it off one pump. Simon probably thinks, especially the bigger pump. And then you get mixing inside that low loss header, which means you need your flow temperature slightly hotter again. And we've got video on distortion, why not to use a low loss header on the channel.
I saw that after that was installed.
Why not to use a low loss header is the reason that you shouldn't have that low loss header, in my opinion, probably. And it's a big property, so you probably would think that you'd need one. But you've got such little heat loss, you're only moving around piddly bits of energy. For example, Simon would probably install with this without the low loss header. If it needed it, he would have allowed to be able to just go and plop one back in, right?
Well, I don't understand why people put those tiny low loss headers at all.
Yeah.
Because
It's not actually doing much.
they're not really designed for heat pumps. They don't give you any additional volume. Those headers are for gas boilers, really.
Because I just looked at it and thought, that looks impressive and cost me a bit.
Oh, that would be the traditional way of doing it, and it's one of these things that we're trying to unteach from the industry. Stop using rule of thumb, think, calculate. If you looked at this property, you would spec a low loss header. You'd probably spec 12 kilowatts, two 12 kilowatt heat pumps as well. But when you did the calculations and went, oh, it's got all this insulation, you realise actually there's very little energy moving it at all. You don't really need to go overboard.
So that plastic pipework, does it go all the way up to the top floor? Those 15 mil pipes, yeah? Okay.
How many floors is this?
Ground floor, first floor, second floor.
I'm wondering if it's running at a really big distortion with a tiny pump on the secondary side. The heat pump's happy because it has flow. Removing that pump, removing that header might cause some flow issues.
If he leaves these controls in,
Yes.
I would be brave and I would rip out all the controls, just use your balancing and have one pump. Way more simple, way less to go wrong, way less faults to have out. Although you're going to be tweaking and balancing quite a lot, once you've done it,
Because what would have happened if you removed that smaller pump and a header and kept all those controls in place and shut all the rooms down, the pump would throw an error.
So your only other issue, which you mentioned earlier on, was overheating. So the thing, you've got air-to-air in places here, that's great. That's great for once you've overheated. The whole thing about cooling and overheating is prevention. So at my home, I have an automated system. I have a double glazed, obviously, bifolding doors, south-facing garden, typical kind of setup. When the house or the kitchen gets to around about half a degree above a set point, that I've got a little thermostat in there, it automates an awning that comes out and shades the kitchen from being overheated. In the winter, it struggles to get half a degree above, so we actually drink up the free solar energy, and then our heat pump outputs less. In order to keep up the sort of demand. Instead of an awning, you can have automated blinds, there's all sorts of automation, but what I've additionally got is if it creeps up another half a degree further, my Velux automatically open and create a chimney effect and cool down the kitchen. And that just allows the free natural cooling that we don't need to be wasting our PV energy. I know it's nice that I'm running it for free because it's got PV, but the grid could use free energy. You can sell it back to the grid. You know, there's lots of other things we can do. There's even ventilation that you can put in properties that literally open and close. So you can have like a 4-inch soil stack that points out the roof with a closed vent on it, and it just opens and it creates a chimney effect to cool down property. That will help you in the summer immensely to have something as simple as that installed. So there's a lot of free stuff you can get as well.
It has to overheat if it's running on a fixed flow temperature, right?
Yeah, I mean, this is going to be firing on and off. The number one thing you can do is weather compensate your rating.
And then you might find that all of those controls are no longer needed. Although adjusting all those flows might be a challenge, especially since you don't have any flow meters on this setup. So we don't know what you're controlling really, unless you put temperature clamps on the pipework.
Exactly. What I would do is, rather than even the temperature clamps, is measure the end result. So go on Amazon, get some cheap little sticky thermostat, little wall thermostats you stick on the wall, and just watch the temperatures. You might have to put two next to each other because sometimes they're out. And then when you see one room slightly hotter, turn that down a bit, one room slightly cooler, turn that up a bit until you've got the balance right. Right. Regards customers using some rooms at 24 and some at 16. I know you want high reviews. I wouldn't give them that option. I would give them the option of the temperature room they've got. And if they open the window to cool it, that's fine. You're losing a little bit because of the weather compensation. Yeah. But overheating, that's bad for the planet, man.
I'm on average saving a ton of CO2 a month.
Yeah.
And generating on average a megawatt of electricity off the solar.
Amazing. Yeah.
And the
you've
irony is I can't export any of it because I don't have an MTS certificate.
Oh, right. Well, that's...
Because the two companies I went to, both went bust. So we're on the second floor, which is a loft conversion. We came up here, raised the ceiling level, again insulated on all 6 sides, but on this section that's a 210mm of insulation, but we're quiet and cosy up here. We do have a problem with a bit of overheating, but again, it's all addressable, thanks to you now.
Yeah, so this is the exact kind of Velux that we would say you can get the automation for, and once you get upstairs overheated slightly, you can auto open. You've also got a loft space just here above the stairs that we could put that ventilation stack in, just put a little grill on the ceiling here, and that will create a draft all the way up the stairs if you open the front door, just to allow sort of airflow to pass, because it's prevention of heat first. Yeah. Then they're not opening windows and things and perhaps letting in noise or whatever. And you've got in-window blinds that, as you're aware, you can automate. I didn't know about the solar-powered in-window blinds. That's cool.
When I get some more bookings, I might just upgrade. But inside the rooms, if I can just show you in, the ThermaSkirt comes up. That's the flow and turn, and it just basically goes all the way around. Where it stops, then you just put an MDF dummy to finish it off.
So there's no underfloor heating here?
No.
And you find those skirtings at 40 degrees are more than enough?
More than enough, okay. Yeah, which was a really pleasant surprise.
They're aluminium, aren't they?
Yeah.
So they're the best conductor you can get.
And those are 2 or 3 pipe?
That's a 2-pipe, actually, and yeah, it's a finned, so it radiates through the skirting board. And again, it's one of those things I saw on telly, thought that's a really good idea, bought it, and then crossed my fingers that it's actually going to work, and it did.
Yeah, if you're this well insulated, you don't really have to worry too much about emitters. That's more than enough. I'd say less insulated houses, this would still work. My idea of the best possible house would be underfloor heating, ThermaSkirt, and maybe even in ceiling heating. Then you can get really low flow temperatures. Or then you get what's called self-regulating effect. Self-regulation effect is where your flow temperature is so close to the room temperature. If your room overheats, your heat source backs off. It stops putting in energy, so it just doesn't overheat as much. Or it can turn on cooling and start taking heat back out of the room. But yeah, it's your main thing here is the insulation. That's what's doing the work.
It's working a bit too well in some respects, but that's a problem I can live with for sure.
These air-to-air units look quite sleek and very compact.
Yeah, those are 9,000 BTU units. I think it's got a maximum 10 amp load. Very easy to install, really easy to run.
Multi-split. So I saw 3 units on the side of the building.
Yep.
And how many internal?
They're all one-to-ones.
Oh, they're right. Okay, so not multi-split.
And only on my flat do I have a multi-split because I'm never using 2 rooms at the same time. But otherwise, because it's all about every room having individual control.
Yeah.
And someone in one room doing something completely opposite to another room.
Yeah.
Which has got me out of a lot of trouble.
Yeah, you can get multi-splits that you can extract the heat out of one room and put into the other there, and that's ultimate efficiency. You can get scops of up to 10 or sears up to 10. Yeah.
Can you?
Yeah. If you're extracting, so commercial that have like heated spaces and refrigeration in the same space. Wiesmann, for example, do. It's essentially just an air-to-air unit.
But is there a unit for domestic that would do that between the rooms?
Yeah, there's. I don't know which manufacturers do it, but they have some sort of reversing valve function in the fridge side, so you can take heat from the house, put it into your hot water, and in between rooms, and it just shifts around the. I don't ask. I'm not. That's not my area of expertise, but yeah, there's units out there that do that.
You won't be able to get a ThermaSkirt in small places like this one, will you? That's only a dummy there.
Yeah. That's a dummy, but you know, if ThermaSkirt will sell you all those bits if you want to. Yeah. And the one thing I avoided with ThermaSkirt was getting under door kits, so I just made sure that all my runs didn't go
They do an
the door.
underdoor kit.
Yeah, basically it's a set of pipes that just take the water under the floor to the next bit of ThermaSkirt. I avoided all of that, just made sure that there were no doors in between.
Yeah.
This was part of the original build, so I was really pleased about the fact that we took this up about 18 inches. The design of the rooms and the bathrooms was actually about how easily I could clean them.
Yeah.
So that's why those toilets would go all the way back to the wall, so I don't have to go clean behind them.
Yeah.
Cupboards off the floor, so I can.
But a lot of hotels or Airbnbs would have just air cons as heating and cooling, wouldn't they? There would be no other heating.
No, they just
They just use
absolutely
that.
right. But between the two, again, it means I can please all customers.
Yeah, I think that you'll get more efficiency out of the wet system anyway. For
Really?
heating
Yeah.
than the air to air.
Oh yeah.
Even with ThermaSkirts because of the insulation levels on this place. Because you've got underfloor heating on full ground
Yeah.
and first floor, or is first floor
ThermaSkirt again. isn't
First
it?
floor ThermaSkirt again.
Yeah.
But his flow temperature is as low as 40 anyway, so the rest of the year he's going to be at like 3.5. I think air to air is only 3, it's got 3.
Yeah.
So I think.
But it's not actually doing much heavy lifting, because if the baseline
that's
temperature is
cooling
80,
really.
Yeah. And no one else in Rye has it. And all the rooms are identically spec'd. The only problem I've got with my battery system is I've gone through 2 firms who basically shafted me on the MCS certificate, which is why I don't have one, so I can't export still.
What about Octopus? I think you don't need MCS for some of their tariffs, do you?
I thought in terms of the local DNO, they wanted to see an MCS certificate because I'm also exporting, or potentially can export, way over the 3 or 4 kilowatts. I had a G99 thing.
The MCS certificate for.
Yeah.
But you could still export less than that. You know, you can limit your inverter, right? You can limit your inverter so you stay underneath that threshold. Then you can access SEG, and you don't need MCS certificate for Octopus. That's
My optimizer is Solar Edge, the inverter is Solar Edge, and my batteries are Pylontech.
right.
So Solar Edge won't immediately talk to them. But you can get these Solar Edge keys,
Yeah.
but basically I just need someone to spec it and install it.
It's a whole world.
What I want, eventually, is people to say, oh, there's a carbon zero place, I'm going to go and stay there instead.
Yeah, exactly.
So Rye's the attraction. There are a couple of hotels in Rye, like the Mermaid, which has been standing there for 650 years.
wow.
People might go to the Mermaid because it's the Mermaid, but everybody else is coming to Rye, and I just want to sort of turn that on its head.